which should take a little less time. It's not as much here. Number 5, when vertically stretching a parent function, are you multiplying by a whole number or a fraction? Okay, so when I vertically stretch, that means it's getting skinnier. So that means I am multiplying by a whole number. And an example, let's use absolute value as an example. It doesn't matter if you use this example or not, as long as you have a number outside of the parentheses or the absolute value bars that you're multiplying, right? So I'm going to say, let's multiply by 100. Who cares? It's a whole number. And then absolute value of x. All right, so there's an example. Horizontally stretching, right? That's when the function is getting fatter, right? The graph is going to get fat because from the sides I'm going to stretch it out. So this time I'm multiplying by a fraction. And it's got to be inside. I'll use the absolute value again. It's got to be inside, so it's got to be a fraction. I'm going to use 1 over 100 times x. Right, so those are two different things. The domain and range, dang it, forgot I drew this before I made copies. Let's turn this into, okay. I think I remember what I did. Hang on. Let me find one. Don't go. Okay. I got your paper right here. So its bottom point is at 3, -5. 3, 1, 2, 3, 4, 5, right? About, this thing is not very accurate right there. And our boundaries are, let me make this wider. Let me make it that wide. Okay, so our boundaries are here. This is not going to be super accurate. You have it on your paper. This stylus isn't the most accurate thing in the world. Okay, and then this is going to go up right here forever, and this is going to go up right here forever. Okay, and then this other one, I'm trying to be quick, guys. I'm sorry. -5, down 4. So about right there. Right there. And this one's going to be absolute value, so it's going to go like this. Okay, it's not exact, but it's okay. As long as your points are the same, right? So my domain, let's use a different color here. My domain, remember, domain is strictly left to right. It has nothing to do with how tall it is. These, yes, they go up to infinity, but that's not what I'm worried about. Domain is strictly left to right. This domain is never going to pass this value, right? It's never going to pass this line, ever. So its boundary is there. I'm going to write it over here at negative, its boundary is at -2. And its right boundary is over here, right? It's never going to pass that line. So that boundary is at 8. Let me draw it a little better. At 8. And it's never going to touch. That's the definition of an asymptote, right? It's never going to touch an asymptote, so we can't include them. Therefore, they're parentheses, right? In terms of range, it does touch that -5. We go from bottom to top. So it starts at -5 with a bracket, and it's going to go up to infinity. Easy peasy. Right. Over here, the domain, this one has no boundary points, it has no asymptote, so this one's easy, just -infinity to infinity. And its range starts down here at -4 in a bracket, and it goes on to infinity. No big deal. Hopefully that one was pretty easy for y'all. Down here, I'm just going to say what the parent function is and then write the things. So this is a square root parent function. First thing I see happening to x is that it's moving to the left 2. Then it's being vertically stretched by 3. And then I see it's going up 7. Right, so this, and I'll color code the next couple so that it's a little easier. But this is that +2. This is that +2. Right? This is that multiplying by 3 on the outside. And this is that adding 7 on the outside. Right? So then let's come down here. I'll color code so it's easier so you can kind of follow better. First, I'm going to add 4. Right? So that adding 4 is going to move me to the... did I do the other one right? Yeah, I did. Okay. Adding 4 is going to move me to the left. And I'll write it out. 4. Right? Then I'm going to have this 1/2 on the outside. That's going to vertically, oh my, okay. Let's write that better. Vertically compress by 2. Right, and then I have this guy over here, and that's going to go down. That's going to make my equation go down 1. Right. Over here, adding 3, that's going to go left 3. And then this negative, remember, is something completely different than saying vertical stretch by -2. The negative tells me I am reflecting across x, right? I'm reflecting across the x-axis. And then finally that 2 is going to do something different. That's going to vertically stretch by 2, right? So remember that negative does not pertain to the 2 at all. It's just telling you there's a negative on the outside. I'm multiplying by a negative. That means I'm reflecting across the x. Same thing down here, right? First thing I see is this negative right there. That means I'm, again, reflecting across x. And then I'm going to add 6 on the outside. That means I'm going up 6. All right, and that's it. I meant to zoom out. So that's it. Right? Hopefully that this helps. I'll be trying to do this a little more often for you guys. I'm getting into technology a little bit, so hopefully this stuff will be beneficial to you. Again, if you have any questions, just feel free to email me. Come in the morning. I'll be there in the morning. So, yeah. Hope you have a good night. Bye. Bye, buddy.